Hello everyone. So welcome to the sixth video on superposition theorem, and we are solving one problem here which is here on your screen. So again, this is part of the playlist on superposition theorem, and one by one I am solving some problems. So here you can see, calculate the voltage drop across 3 ohms resistance. So there is a 3 ohms resistance here, and we need to calculate the voltage drop across that 3 ohms resistance, which means we have to find the current first, so that I can multiply by 3 and I'll be getting the final answer. And we want to use the superposition theorem for this. Now, for doing this, we can consider one source at a time. So if you're already aware of superposition theorem, you can pause the video here. You attempt to solve it by yourself, and later you compare your answer with my answer. So right now I'll go ahead and solve this problem. Let's see whether how we'll be getting the answer. Okay, so consider 20 volts source. So when I'm considering 20 volt source, so then my circuit becomes something like this. See, the voltage source has to be short circuited, the others, and the current source have to be open circuited. So these two current sources will be open circuited. So I'll get a circuit like this. This is 6 ohms, this is 2 ohms, and this is 1 ohm. And then this is 20 volts, and finally this is 3 ohms. So now I need to find the current in the 3 ohms resistance. So one thing, the direction of the current is downwards here I can get. Okay, so this let us denote as I1. So what is I1? So for that I need to find the effective resistance. So 2 plus 1 is in series, that is in parallel with 6, and that overall thing is in series with 3. So the effective resistance is 2 plus 1 in parallel with 6, and the overall thing is in series with 3. Okay, so now 2 plus 1 is 3 in parallel with 6. So that is nothing but 6 into 3 divided by 6 plus 3, that is 9. So I am getting 2 ohms. So this is part is 2 ohms. Again plus 3 is my total resistance, that is 5 ohms. Okay, so sometimes we can just do it with the observation. Now what will be the current, total current? So that will be V by R. So I1 is nothing but 20 by 5. So that is 4 amperes. Okay, so the total current 4 amperes goes here, that divides here, which we are not worried right now, and again combines here to get 4 amperes, okay, which is flowing through the 3 ohms resistance. So now I got I1. So I1 is done, simple, easy. Now let's take the 12 ampere source. Okay, so let's take the 12 ampere source. Consider 12 ampere source. So now this 10 ampere source will be open circuited and this will be short circuited. So then if you see, this 3 will be down here. Yeah. So let me draw the circuit and see what happens. So this part is short circuited. Then I have a 3 ohm resistance here. Then I have a 2 ohm resistance and a 1 ohm resistance. And then I have a 12 ampere source, and then this is short circuited, and here I have a 6 ohm source. Okay, so now we need to analyze this circuit. So let's little bit reorganize this thing. Okay, so now here a little bit tricky part, actually this is not very easy to solve. Here what is happening, it's not as a series parallel combination, it is a star delta kind of combination. So 6 ohms, 2 ohms and 3 ohms are forming a star network here, so which has to be converted to delta, then it will be able to resolve into easily into series parallel combination. But let me cheat a little bit, and I will try to solve it using Thevenin's theorem. Okay, so right now we are studying superposition theorem. As a part of superposition theorem, I am taking one source at a time, and now I am coming to taking a 12 ampere source. So our objective now is to find this current, which we will denote as I2. Okay. So now to find this I2 current, there are several ways, but easiest way is to use a Thevenin's theorem. Okay. Now Thevenin's theorem I will be later making a one more separate playlist in future, but just follow it through me. Okay. So here what I will do using Thevenin's theorem, to find current in 3 ohm resistance. Okay. So how do you find current in the 3 ohm resistance using Thevenin's theorem? So first thing what you have to do is remove load resistor. That means our 3 ohms resistors we have to remove, and then open current sources and find equivalent resistance. Okay, so let me explain what it is. So here in this circuit, I will remove the open circuit the current source and remove the 3 ohm resistance and find the resistance between these 2 points. Okay, so I'll get something like this: 6 ohms, then 2 ohms, then here it is open circuited, then here it is closed. Here I have 1 ohm, and then between these 2 points I have to find the RTH, Thevenin's resistance. Okay. So if you notice here, the resistance between these 2 points, that means the resistance between this point and this point. Okay. So here I have 2 parallel branches, 6 parallel with 3. Okay. So this is like finding the resistance between 6 ohms and then 2 ohms and 1 ohm, like this. So 6 parallel with 3. Okay, so what is 6 parallel with 3? 6 into 3 divided by 6 plus 3, that is 9. So we have 2 ohms. Okay, so the Thevenin's resistance is 2 ohms. Now I need to find the Thevenin's voltage. Okay, so bring back the current source and find the Thevenin's voltage. Okay, voltage across these 2 points. So the circuit becomes like this: 6 ohms, 2 ohms, then we have the current source 1 ohm, this is 12 amperes. Now I need to find the voltage between these 2 points. So this is A and B. So I need to find VAB. What is VAB? So to find VAB, we have to use the Kirchhoff's current law, KCL. Okay, how do you find this VAB using KCL? Use KCL from B to A. But before that, let's calculate the currents. See, this branch is a series of 6 and 2, and this branch is only 1 ohm. Okay, so the current of 12 amperes is dividing into 2 branches. So what is the current in this branch? So let me write that. So that is 12 into opposite branch is 1 divided by total 6 plus 2 is 8 plus 1 is 9. Okay, so 12 by 9. So this is, let's call it IA, and let's call this as IB. Okay, so IA is 12 by 9. Okay, so that is 12 divided by 9. So 1.33333 amperes. Now what is IB? Okay, so IB is coming like this. So that will be 12 minus 1.33, or I can say 12 multiplied by 8 by 9. So that will be 12 by 9 already we have. So multiply by 8. So I'm getting 10.667. So I got these 2 currents. Now I'll apply KCL from B to A. So the current is going like this, IA, and then here the current is coming IB. So here I am losing the voltage. Okay, so VAB is KCL from B to A. So from B here, that is, I am losing the voltage because I am going in the same direction of current. So high voltage towards low voltage. So minus 2 into 1.3333. Then here I'll gaining the voltage. So plus 10.6667 into 1. Okay, so this is the total VAB voltage. So that is minus 2 into 1.3333 plus So I got this number plus 10.667. So I'm getting exactly 8 volts. Okay, so this is the 8 volts. So this is nothing but Thevenin's voltage. So now I can make a simple Thevenin's equivalent circuit like this. So this is 2 ohms and this is 8 volts. So this is my Thevenin's source, and this one will be connected across our load resistance, which is 3 ohms. So now finally, what is the current I2? Okay, so this current I was denoting as I2. So this is nothing but 8 by 2 plus 3. Okay, so 8 by 5. Okay, so 8 divided by 5. So I'm getting 1.6 amperes. Okay, so 1.6 amperes is the current. So finally, we solved current due to 20 volts is I1, that is 4 amperes, and current due to 12 amperes is I2, that is 1.6 amperes. Next, let us find the current due to 10 amperes. Okay, so I need to go to a new page. Okay, so let's redraw this circuit again here with only 10 ampere source. Okay, so what do I have? So I have the 6 ohms as it is. Now this 12 will become open circuited. So this is 2 ohms and 1 ohm. 20 volts becomes short circuited, and then I have 10 amperes here, and then I have a 3 ohms here. Okay. So now this current, let me denote it as I3. So now the objective is to find I3. So here considering 10 amps source. So this is our new problem now. So here notice that the current going down, it may go up in this direction. So the I3 may become negative. So that is one point you need to know. And the other thing, again, this is cannot be simply resolved into a series parallel combination, because there is a star point involved here, or a delta is involved. 2, 6 and 1 becomes a delta connection. So instead of worrying about all that, again I will use Thevenin's theorem. Okay, so consider this as point A and point B. Okay, so points A and B. First thing is I want to find the Thevenin's impedance. Okay, so how do you find Thevenin's resistance or Thevenin's RTH? So nothing but remove this 3 ohm resistance and open the current source and then draw the circuit. Okay, so I am getting 6 ohms here, and then 2 ohms here, and then 1 ohm here, and then this is closed. So this is point A, and point B is nothing but point B is here. Okay, so what is the resistance between points A and B? So there is one branch which is 3 ohms, other branch which is 6 ohms. So nothing but 6 parallel with 3, that is 2 ohms is the RTH. This is exactly same because the circuit is same as before. The structure of the circuit is similar. Now I want to find the VTH, Thevenin's voltage. So how do I find the Thevenin's voltage? We reintroduce this 10 amperes and then again solve the circuit. Okay, so let's do that. 6 ohms we have, 2 ohms we have, 1 ohm. Then I am having 10 amperes going down. This side it is short circuited, and this is closed, and this side it is open circuited. Okay. So now how will be the current flow? So this point is A and this point is B. Okay. So now I can redraw this circuit in this manner. So I am having one branch, so that is coming here, and then this is the other branch. Okay. So I'll just redraw this circuit like this. There is a 10 ampere source, and the outgoing part of this 10 ampere source is called point B. Okay, so this point is B, that is going and splitting into 2 and 6. Okay, so that is splitting into 6 ohms and then 2 ohms. So after splitting into 6 ohms and 2 ohms, the 2 ohms part, it is directly coming back to the negative terminal of this circuit. So basically it is like this. So this is 1 ohm, and between the 6 and 1 we have point A. Okay, so this is point A. So this is our circuit. So it is now very easy to find the currents here. So let's call it IC and ID. Okay, so what is the current IC? IC will be 10 amperes multiplied by 2. So IC will be 10 amperes multiplied by 2 divided by 6 plus 1 plus 2, that is 9. 6 plus 1 plus 2 is 9. So this is simple current division. So 20 by 9. So that is 20 divided by 9. So 2.222 amperes. Next, ID I will calculate. What is ID? So ID is nothing but 10 multiplied by the opposite resistance, that is 7 divided by 9. Okay, so 10 by 9. Okay, so 10 multiplied by 7 divided by 9. So I'm getting 7.777. So I got both the currents IC and ID. Now I need to find VAB, so voltage of A with respect to B. Simply I'll apply Kirchhoff's voltage law from B to A. Okay, so what is that VAB? VAB is nothing but KVL from B to A. So I started B. Now if I go here, you notice that my current direction, I'm in the same direction, so voltage is reducing like this. So VAB will be negative. So VAB is nothing but minus 6 into, what is the current? 2.2222. So that current will be 6 into 2.2222. So 13.33 is the voltage. Okay, so 13.333 is the voltage. So this is nothing but Thevenin's voltage. So now I will construct the Thevenin's equivalent circuit. What is the Thevenin's equivalent circuit? 2 ohms is the Thevenin's resistance. 13.333 volts is the voltage, and then my load resistance is 3 ohms. So now I want to find I3 current. Okay, so through this branch. Now I'm sorry, I forgot the minus sign here, so there will be minus here. So this one will be minus 13, or I can keep like this. This is the minus and this is the plus. So I have reversed the direction, and therefore I3 will also be minus in this case. Okay, so what is the current I3? So that will be voltage divided by V by R, so divided by 5. So 2.667 is the current. So minus 2.6667. So now this is the current. So let us calculate the total current. Okay, so the total current using superposition theorem is I1 plus I2 plus I3. So I got I1 value, if I go back to this one, I1 value was 4 amperes. So 4 plus I got I2 value of 1.6 amperes. So 1.6 amperes, and then I3 is minus 2.667. Okay, so finally my current is like this. So 4 plus 1.6 minus 2.6667. So 2.933 amperes. Okay, so this is my final answer of the problem. So if you also solve this problem, you might have used a different method, and finally if you arrived at this answer, good. So your answer is correct. And if your answer is different, then maybe I have made a mistake or you have made a mistake. So we need to verify. So please cross check and let me know whether my answer is correct or not. So basically, to review what I have done, I have been given a problem with 3 sources. So when in the matter of using these 3 sources and solving it, I found the reason to use a Thevenin's theorem in between the superposition theorem. So that is the thing. Anyway, so finally we were able to get the answer. So this is the final answer, 2.933 amperes. So if it matches with your answers, let me know. Then we will confirm that the answer is correct. Thank you so much. If you like this video, please press the like button and you follow this. I am making a series of videos. So as of now, one more video I am going to make, that is the 7th problem. So let's just wait for it. That is there in the next video. Thank you.